All right, this is our first stop in our Plant Invasions virtual field trip. We're here in the Clemson Experimental Forest. I actually have a lab assistant with me today. This is Aster. That's my daughter. She's 5. Aster, tell us what kind of trees that you see around here.
Oak, American beech, pine.
Okay. Anything else? No. Yeah. So, like Aster said, pretty typical late successional Piedmont forest, dominated by oaks. We do have some small American beeches, some bigger ones down here, down the hill in the more Mesic site. Not a whole lot of pines, but there are a few of them. What's your favorite tree?
Yellow poplar.
Yellow poplar. Yeah, so yellow poplar is something, if we went down into more of a Mesic site, we might see some of that. But that just goes to show you that, you know, our sense of place is largely defined by plants, native plants, and, you know, maybe this suggests that we start to form those associations at a very young age. So the theme for this first stop is the advancing front. So what you can see here is a mature, late successional, mostly hardwood forest, typical like what you might see throughout the Clemson Experimental Forest. And by and large, it is not invaded. You'd have to look really hard to see a lot of invasive species here. Nice open understory, overstory, mostly dominated by deciduous late successional hardwoods. And if you look really closely, there in the forest floor, there's a lot of oak and hickory regeneration, so young oaks and hickories coming in, suggesting that you know, we're approaching more of a climax state here. But it's the advancing front, so what I'm going to do is rotate around here. Same forest. That's what the invaded area looks like, right? Uninvaded over here, invaded over here. You can see that leading edge, that advancing front. And it's got all your usual suspects. Of course, you've got Chinese privet, you've got silverthorn, and you know, a few other things. We got a couple things. What do we have right here, Aster? We got this right here, Japanese honeysuckle, right, climbing up over everything. This is actually the most widely distributed invasive plant in the South, Japanese honeysuckle. And a little bit of this stuff right here. This is called Nandina domestica. So what I want you to take away from this is this idea that alien invasive plants can dramatically impact just the overall structure of a forest, going from being open and park-like here on the uninvaded side to extremely dense, thick, and, you know, quite, you know, thicket-like here on the other side. So you could just about run through the uninvaded side. This invaded side, where you have all of these different alien invasive plants, I mean, you'd be hard-pressed to walk through it. These plants have all of those characteristics that we talked about in the pre-lab lecture. All of them have ruderal characteristics. They're highly resource use efficient. You know, think about it over here. One of the reasons why this side of the forest, why there's relatively little growing in the understory, is that for most of the year, for the growing season, there's just not enough light, right? We have the same canopy over here, but a couple of adaptations these species have. One, they've got leaves in the dormant season. That enables them to capitalize on the light that's available in the dormant season. And then two, once the sun, or once the canopy does leaf out, they're pretty shade tolerant. Right? So they're adapted to those more shady conditions and can thrive in that environment as well. So they dramatically change just the overall character of the forest. And I don't really want to go in there and look around too much in the understory, but I mentioned that you know, over here in the uninvaded side, you have a lot of oak regeneration and hickory regeneration coming up. Over there on that side, I think you'd be hard-pressed to find any of that, because it's just too shady and too competitive of an environment. Even if a little oak seedling did manage to germinate over there, it's going to have a very hard time competing with these established invasive alien plants. And so, you know, it's the likelihood that it ever becomes an adult tree is going to be pretty slim. So we're kind of touching on some of this idea that you know, these species can actually alter successional trajectories potentially leading to the development of a novel or no analog community. We're going to hit on that again when we get to our last stop. Anything else to add, Aster? No? Nothing? How's your online learning going? You enjoying not being in class? Yeah? Pretty good?
Yeah.
All right. All right, so we're going to go to our next stop, which is the disturbance site. All right, well, our theme for our second stop on the invasion ecology field trip is disturbance. And I'm here in a disturbed site, and there's a plant here. You can see it's died back from the winter time, but it's still there, growing up over these trees and all over the ground. Some of y'all probably know what plant this is. I mean, you can't really talk about plant invasions in the South without talking about this one. Yeah, this is kudzu, probably the most well-known invasive plant in the South. And before we get talking about disturbance, I just want to tell you some interesting stories about kudzu. Kudzu was brought to the United States in 1876. It was introduced at the Centennial Exposition, so the United States was 100 years old, at the World's Fair. I believe that was in Philadelphia in 1876. And it was advertised as sort of a wonder plant. It'll grow anywhere, even in the worst of soils. It's edible. The flowers smell good. Livestock can eat it, people can eat it. And it's just great for erosion control. And so it was introduced at the Centennial Exposition at the World's Fair, along with some other interesting things, just some fun facts. Bananas. Bananas were first introduced to the United States at that Centennial Exposition. Ketchup was also introduced. And what else? I believe the typewriter was introduced. So a lot of interesting and important products and things were first brought to America back in 1876. So kudzu was introduced. It never really took off then. It was just sort of a curiosity. But then in the early part of the 19th century, up until about the Great Depression, people started paying attention to kudzu again. Kudzu, like I mentioned, grows really well in eroded sites. And so thinking about the situation we were dealing with during that period, we're coming towards the end of a very long period of unsustainable agriculture. And agricultural productivity was declining due to just lots and lots of erosion. People were mainly just planting monocultures of cotton, and ultimately they would have to abandon those lands when they became too eroded to produce cotton anymore. And kudzu was introduced basically as a soil rehabilitator. You can kind of see I'm right in the middle of it right here. Look at all of it. Look at the kudzu growing up over the trees. The kudzu that you're seeing is not dead. It's just died back from the winter. It's going to come back. And so it's a soil rehabilitator. So it does really well in those soils that have been heavily disturbed, heavily degraded from agriculture. And you could actually go down to your local extension agent, this is a true story, and say, hey, I've got a soil erosion problem, can I get some of that kudzu? And they would give you some. They'd give you some little cuttings of it. And it would even come with planting instructions. They would say, stick it in the ground and run away. And that's a little bit of an exaggeration, but it does grow tremendously fast, even in the poorest of the poor sites. And one of the reasons why it grows so well in those really poor sites is because those poor sites are usually pretty nitrogen depleted, right? Growing cotton year after year after year depletes your soil nitrogen. It's one of your plant essential macronutrients, often limiting. And kudzu can do well in those sites because it's a nitrogen fixer. It's not dependent on there being a lot of nitrogen in the soil. And so it was planted as a solution to that problem, and bottom line is it worked. You know, you hear a lot about the bad stuff related to kudzu nowadays, but back then we have to recognize that You know, folks weren't concerned about invasion ecology back then and the consequences of invasion. They were worried about agricultural productivity and soil erosion, and quite frankly, this was a great species for slowing and stopping some of that soil erosion and then replenishing some of that nitrogen back into the soil, right? Because as a nitrogen fixer, it does have very nitrogen-rich tissues, and as you can see, it dies back every year. And as it dies back, you get nitrogen mineralization. It's adding nitrogen to the soil. The problem with kudzu, though, is that you're stuck with it, right? So it's very difficult to get rid of once you have it. So, you know, you end up with situations like this. This was probably an area where kudzu was introduced for erosion control because it was heavily disturbed, heavily degraded. And many, many decades later, we still have lots of kudzu. So, and you can see it actually can kind of creep into the woods. It can, there used to be some over on the other side over here where it was growing up into the trees. But y'all have seen pictures of what a serious kudzu invasion looks like. So, kudzu served its purpose, but now we're stuck with it. And this probably, like I said, is one of the most well-known, if not the most well-known invasive plant in the South, probably because it is so visible, right? When you see kudzu just consuming a whole forest like this, right, there's nothing else that looks quite like it. I've seen various estimates as to how much kudzu there is in the United States and in the South. I think it's somewhere around 1 million acres, which is quite a lot. But in reality, compared to some of the other species that we have, it's probably not even in the top 10 in terms of acreage. I mean, Japanese honeysuckle is way more. Chinese privet is probably, we've got way more of that as well. But this one is the most visible. So it is pretty invasive, but it does require a lot of light. So you're typically not going to see it invading into the interior of the forest. So you'll see it invading in these nice open areas, and it might climb over some trees at the edge of the forest, but it's not very shade tolerant. But you can't talk about invasive plants in the Southeast without talking about kudzu. Kudzu, again, is one of those species that really benefits, really does well in those sites that are heavily disturbed. And this is just a really good example of that. So we're going to walk across the road and continue our discussion about disturbance here in a second. All right, so we have walked right across the road from where we just talked about kudzu. Again, we're still talking about disturbance, and as we walk up to this next spot that I want to show you, I want you to see if you can discern what type of disturbance or types of disturbances we've had here in the past. One of them should be pretty obvious. The other one might be a little more subtle, but it's here. Yeah, so there's been two main disturbances here. The first one would be agriculture, the same disturbance we saw on the other side of the road. You can see this really throughout the Clemson Experimental Forest. That's where I am. And you've got these agricultural terraces right here. This is a terrace right there. You can see that right there, how it drops off to the right side of your screen. All right, so these agricultural terraces were put in really around the same time the kudzu was planted. Basically, it was just an attempt, a last-ditch effort to put down the effects of soil erosion. Right, so they would terrace this land. That would slow the water from running off, trying to keep that soil in place. But it was, in the end, it was just too little too late. But those terraces are still around as a reminder of that previous disturbance regime that we've had here. And then the other disturbance, a little more obvious. You can tell this area has been burned, actually been burned pretty recently. This particular site, I believe it was last burned, I want to say in 2019. So it has a history of fire. And fire is another type of disturbance. We haven't really gotten into fire too much in class and how fire can influence nutrient cycling, but it certainly can. One of the ways that fire influences nutrient cycling is that it primarily consumes your leaf litter. And as we know from class, your leaf litter is your primary source of nitrogen, right? So as that leaf litter decomposes, that nitrogen gets mineralized and put back in the soil. But when you have a fire that consumes that leaf litter, effectively what that does is that it is going to magnify your nitrogen limitation. Now, these systems would have naturally been nitrogen limited, so that's not necessarily a bad thing. However, last site, that nitrogen limitation can oftentimes favor those nitrogen fixing invasive plants. I'm trying to find this little patch. It's been burned up sometime recently. Let me see if I can find it. All right, well, I have found what I was looking for. I got a little disoriented there because it has been burned since the last time I was here. And admittedly, this doesn't look like very much, and it's mixed in with some other things. But what we have here is a patch, there's some right there, of a species that's called bicolor lespedeza. It's another nitrogen fixing plant, same family as kudzu. And just like kudzu, this is a species that's going to thrive in a nitrogen limited site, right? So we've burned off a lot of our litter here, our primary source of nitrogen. So we've magnified that nitrogen limitation and created an environment where a species like bicolor lespedeza can potentially thrive. Right? Now, fire is a natural process here, don't get me wrong. However, we have to be mindful of when we are using fire, it is a disturbance and it is going to favor those species that have ruderal traits, particularly some of those unwanted. So there's your bicolor lespedeza. Now, what I want to talk about here was how fire can alter or disrupt important ecological processes. We mentioned this in the pre-lab lecture. Most of this forest looks like this, right? There's not a whole lot of understory, there's not a whole lot of fuels, there's just enough to carry a pretty low intensity fire. But imagine when that fire hits this, right? Think about how that fire might behave differently. Right? Over here, not much fuel, all that fuel is pretty low to the ground. And then over here in this patch of bicolor lespedeza, right? We've got fuels that are 6 or 7 feet tall. All right, so fire is going to behave differently here. It's going to get hotter. The flame lengths are going to be higher. You can see that on the trees. If you look at some of these trees around this patch of lespedeza, some of them have char heights that are 20 feet tall. All right, so you can just imagine when that fire hit that, it blew up and got really hot. Compared to over here, most of your char heights are more on the order of 3, 4, maybe 5 feet tall. Right, so it's a good example of a species that's altering an important ecosystem process by changing fire behavior. Sericea lespedeza is a species that's, bicolor lespedeza. Sericea is another invasive lespedeza. Sericea and bicolor lespedeza are both species that are actually still planted to this day. Bicolor lespedeza is planted a lot in wildlife food plot mixes. People like to plant little patches of it, for example, out in their quail plantations because it provides this dense cover. It also produces a lot of seeds that various types of birds and other organisms can eat. Right? We are moving a little bit away from using bicolor lespedeza in our food plots and for wildlife purposes because we are recognizing that it is invasive. But just like the kudzu, just because you stop planting it or cut back on planting it doesn't mean that you don't still have a lot of it out on the landscape, and it does have a tendency to reseed. Right? So stop number 2, that is disturbance. Talking about how disturbance can facilitate these species, particularly those ruderal species with nitrogen fixing ability. They tend to thrive really well. This is our third stop, and we're talking about the human legacy of invasions. You look around here, we have, well, there's Astra again. There we have a lot of this plant growing on the forest floor. Astra, what kind of plant is that?
English ivy.
English ivy, yeah. So English ivy is quite a common invasive species around really all over the southeast, and it's all over the Clemson Experimental Forest. And I call this stop the human legacy of invasions, just based off of what we know about the history of the Clemson Experimental Forest. You guys probably already know this. The Clemson Experimental Forest, before it was forest, if you go back to colonial times up until about the Great Depression, it was mainly small farms. It wasn't really forested at all. But those farms were abandoned in the early part of the 20th century. And then Clemson acquired the land. Secondary succession happens. And now we have the Clemson Experimental Forest. But those old farmhouses, they're long gone. But the vegetative legacy of the people that used to live here remains in many cases. And this is a good example of this. English ivy is a traditional southern porch vine to this day. People still like to plant it around their homes. And even after the homes are gone, it remains. You can see it here. And those old home sites are oftentimes little epicenters for local invasions within the forest. So anytime you're out in the forest and you see a clump of English ivy, or maybe a clump of some large non-native bamboo, pretty good indication that you're probably near some sort of old home site. And if you look around, you might see some old pots and pans, maybe some bricks, some indication that a home might have been there. But some of the adaptations that English ivy has to make it such a successful invader, it is evergreen, right? So it keeps these green leaves all year long. And that enables it to photosynthesize year-round and capitalize on the light that's available in the winter time when the overstory doesn't have leaves. Very resource use efficient. Not a whole lot of light down here, but it nonetheless manages to produce all of this biomass. Right? And as much biomass as you see above ground, if you were to dig down below it, you would see that it has a dense network of roots as well. Right? It's also very plastic. If you look at English ivy, it grows all over the ground like a ground cover. It also grows up trees. Right? So very plastic in its morphology, and that contributes to its success as well. The light that it's capturing and the energy that it's creating, from being up in the canopy and having more access to sunlight, it's pumping that energy down to the forest floor to fuel the growth of the understory here. Right? But it can have some impacts, right? This dense layer, this mat of English ivy has some implications for succession. I mentioned how dense it is below ground, and you can see how dense it is above ground. Very difficult for native trees to regenerate through a dense patch of English ivy, and you don't see a lot of oaks and hickories, certainly not any pines, even though we do have some pines in the overstory, managing to regenerate. So the species is, just by its very presence, is altering our successional trajectories. It also could harbor some plant diseases in its roots, which can then get transferred to oak trees, and then oaks, when exposed to English ivy, oftentimes succumb to those diseases and die. All right, so the human legacy of invasions, one of many examples we could show you, but English ivy is probably, I'd argue, the most noteworthy one. You're going to see little patches of this all around the Clemson Experimental Forest. Those patches are likely 100+ years old. Now on to our next stop, the invasion meltdown. This is our last stop. This is the invasion meltdown stop. And as you remember from my recorded pre-lab lecture, what an invasion meltdown refers to is that feedback loop, that facilitation among different species of alien invasive plants. So let me just step back a little bit so you can see what we're looking at here. A little area here where they've cleared out some invasive plants. But by and large, everything around me that you see from about 15 feet down to the forest floor is an alien invasive plant. Right? We do have a nice native overstory comprised of oaks and hickories and things like that, mostly late successional stuff, but just tons and tons of invasive plants here in the midstory and understory. Before we get into the details of how this happened, how this forest developed like this, let me just tell you a little bit about the forest where we are. So we're over here by let's see if you've ever been here before. This is the Fort Rutledge Monument, kind of over here by Clemson's sewage treatment plant, over here on the dike, right there by the lake. And what this site is essentially an island. right? It's a forest fragment. We've got water on one side, we've got a golf course on the other side, a grassy area on the other side. It's just this isolated little patch of forest. And when we talk about how this site got the way it is, I think it is helpful to know sort of some of that geographical context. Right? So, how this happened? Right? So we're transitioning into late succession here. We got oaks, we're starting to get some hickories and stuff. But we're not all the way to our climax state. Right? We really don't have a whole lot of hickories. So in order to get to that latter stage of succession, the hickories have to arrive. Right? But how are they going to arrive if this site is isolated from other forests? Right? Those later successional species typically have large seeds, and they're not dispersed very far, so it would be very difficult for oaks and hickories, particularly the hickories, to arrive here. I've never seen a squirrel run half a mile with an oak or a hickory nut. Right? But it's actually not that difficult for these alien invasive species to arrive, because nearly all of them, actually I think everything I see, Chinese privet, silverthorn, nandina, and a few others, are bird dispersed. Right? So a bird could eat a silverthorn or a privet drupe a mile away and come perch in one of these oak trees and then poop out that seed, and it gets established. So just by virtue of our isolation, the fact that we are this isolated little fragment, that's going to tend to make this site more susceptible to invasion. Right? We do have oaks and a few hickories in the overstory, but as you can see here in the understory, nothing. Right? There are no oaks and hickories down here, like we talked about at that first site, just too shady and too competitive of an environment. So what's going to happen is these oaks and hickories die. They're not going to get replaced. Right? So you're going to see this forest just more and more transition into a non-native shrubland over time. But you can envision how you might get some facilitation, some feedback between the species that you have here. Right? Envision, let's say Chinese privet is the first species that arrived, then a bird lands on that Chinese privet, poops out a silverthorn seed. Right? Silverthorn's very shade tolerant. Silverthorn can germinate and establish in the shade of that Chinese privet. Now you've got Chinese privet and silverthorn. Right? Then you've got English ivy and species like Japanese honeysuckle. There's Japanese honeysuckle right there that can then exploit that vertical structure that's created by the Chinese privet and silverthorn. They can establish on the forest floor and climb up. So one species facilitating another species, facilitating another species, right? That's the invasion meltdown hypothesis. You can see it happening right here in this site. There's Aster again. I think she's losing some patience. We got species from all over the world, but just by chance, by the fact that they share those invasive characteristics, there's English ivy again, have managed to converge right here in this site and take it over. You can see that some people have made some efforts to remove some of these species. Probably about 1/10 of an acre. Looks like it's been cut up, chopped down, probably treated with some herbicide. But just a tremendous amount of work it took to do that, considering that we probably have about 10 acres surrounding it that look like this. Right? So increasingly, this is the scenario that we're faced with throughout the world. Right? This invasion meltdown hypothesis. Our forests, our natural lands are increasingly being fragmented. That's going to reduce the likelihood, make it more challenging for those late successional large seeded species to arrive. But then those invasive species that have ruderal characteristics, plasticity, highly competitive, they have no problem arriving and they take over. So what does this all mean in the end? Right? If this is increasingly going to be the reality of forests and natural areas around the world, what can we do about it? You can come in here with chainsaws and herbicides, and yeah, it feels good to cut down invasive plants. But is it going to be a never-ending battle? Just because I cut down that silverthorn right there, it doesn't mean that an oak or a hickory is going to show up. Right? These non-native invasive species still have that competitive advantage. They're already here. Right? So this gets to the idea of, oftentimes with invasive plant control, we're faced with the task, hey Astor, of removing them, right? And you can feel like you're accomplishing something, and sometimes you can, right? But more importantly, we've got to think about, are we addressing the true root cause, right? Because in many cases like this, when you're dealing with a fragmented landscape, those non-native species, those alien invasive species, are just a symptom of a larger problem, that fragmentation. You're always probably going to be dealing with invasion issues if you don't address that fragmentation issue by connecting your landscape. Likewise, going back to my Wakulla Springs example from the pre-lab lecture, right? That hydrilla is just a symptom of a bigger ecological problem, and that bigger ecological problem is nutrient enrichment. Right? The reason why hydrilla can grow so crazy in Wakulla Springs is at least in part due to the fact that it's just downstream, if you will, very close to Tallahassee, Florida, and other places that have, lots of septic tanks leaching phosphorus into the soil. Aquatic systems are phosphorus limited, right? And so you add that phosphorus, it's going to result in a lot of plant growth. You can pull up those plants, but as I saw, they're just going to keep coming back. To truly address that issue, you have to address the underlying cause, not the symptom. And in many cases, the plants are just a symptom. Don't get me wrong, there is good reason to try to control invasive plants. We talked about that. They're a major contributor to biodiversity loss. But we have to recognize that you really have to get to them early, right? These invasive plants here would have been a lot easier to control if we recognized the problem early and got it before they'd completely taken over. The cost and the effort associated with control is going to increase exponentially the longer you wait. Right? Let's pan around here a little bit, see how dense it is. It might also be worthwhile to recognize that these plants do provide some value as well. And this is kind of a tough pill to swallow, and I am kind of being devil's advocate here. But when Astor and I walked up here today, a rabbit ran off into the woods. Cottontail rabbit ran off into this thick stuff. It does provide some good cover. But these plants around, well, they're benefiting by having, those sweet and nutritious fruits to consume. Abundant sweet and nutritious fruits. Right? So you have to, I think with invasive plants, recognizing that it is a huge global problem that realistically we're not going to totally conquer. To some extent, I think it is worthwhile to acknowledge that they do provide some benefits. A little more devil's advocacy here. What is a native plant? The whole idea of an invasive plant is based on this idea that some species are supposed to be here and some species aren't. Right? And those species that are supposed to be here, and I'm doing this, supposed to be here, those native species are here because they are adapted to the historic soil and climate conditions of the area. Well, we've modified the soil. It's very different from what it historically was. And the climate is different. The climate continues to change, right? So in a changing world with an uncertain future, where the climate of the future is no doubt going to be different from the climate of the past, does that change our idea of what native is? What if the climate changes to the point to where the species that were historically here can no longer grow here at all? Do we keep trying to restore those natives? Or do we recognize the value of these novel ecosystems like this? Not saying we should, not saying we shouldn't, I'm just saying it's something that's maybe worth talking about I will say millions of dollars that were spent every year in the United States for control costs for a battle that, oh, we might be winning some battles, but I wouldn't say we're winning the war. Is it worth it? And what would it take if our goal was to beat invasive species and to remove all of them? What would it take if the billions that we're spending now isn't enough? Where would we get that money? Right? What would we not fund in order to do that? And is it worth it? Again, I'm not saying you should, these are just philosophical questions that I'm asking here. I'm not telling you what you should think or even what I think. But some food for thought, something to think about. It certainly is a complex, nuanced issue, plant invasions. There's not an easy answer to it. Philosophical question as much as it is a scientific one. So I hope you enjoyed the virtual field trip and the pre-lab lecture for invasive plants. If this is the kind of stuff that interests you, just reach out to me. I've got a bunch of papers and things that I'd be happy to share with you. I'd love to sit down and chat with you, whether it's in person or virtually, because it's just an intriguing topic to discuss. Hope to see y'all soon. Take care. Go.
Thanks for watching.